Okay, so now we're going to be using our stuff kind of from our dynamics unit again with FN and FF and stuff like that too. So let's do an example. So coal exerts a force of 20 newtons to push a 5.5 kilogram crate 1.35 meters along a horizontal surface at a rate of 2.7 meters per second squared. So determine the work done. All right, so that's A. So I'm going to set, this is F app, so the force applied is 20.0 newtons. And we should draw a picture, really. Free body diagram. So here's F app, and it's in the direction of motion. Okay, so there's my motion. So then I can say theta is 0 degrees. So therefore I can conclude that cos theta is equal to 1 for this circumstance. Yeah, I'm just going to write out everything else. So here now too, my displacement is 1.35 meters. I'm trying to find work done by coal. So I'm taking the force applied by coal over the displacement that he went. So I should have put here work equals force times distance. And I know cos theta is 1, so I'm just going to leave work equals force times distance. So it should be meters. So work then is 27.0 joules. But then it says, what is the work done by friction on the cart? Okay, so now we are looking for FF. So let's make our FNet formula. So FNet, if I was to complete this, FF is opposing FApp. So my FNet is equal to FApp minus FF, because FF is going in the opposite direction of FApp. So see how we're kind of remembering all of our dynamic stuff now? Okay. So if I'm going to rearrange that to solve for FF. So FF is equal to FApp minus FNet. So I just brought FF to this side, so that makes it a positive, and brought FNet to this side, making it a negative. Okay, so now FF is equal to FApp minus, now FNet is always M times A, always, okay? So then FF is equal to my FApp, which I just found, or which I was told at the beginning, was 20.0 newtons. Okay, now I know my mass is 5.50 kilograms, and I times that by the acceleration, which I was also told at the beginning. So now if you put this all into your calculator at once, make sure that 5.5 and 2.7 are in brackets together. So plug that in, and FF is equal to 5.15 newtons. So this is the force of friction, but I was asked, let's read the question again. Let's read B again. Work done by the force of friction. So what I should have put here is I'm looking for like FW, or WF, sorry. But I needed my force of friction. So like at the beginning, WF is equal to big F times by D. Times by cos theta. Okay? That's why I found FF first. Okay? So sorry, I didn't put that at the beginning. So that's our FF, but now I need to do a second step to find WF. So WF is equal to FF times by D times by cos theta. I had said at the beginning cos theta is -1. So WF is equal to 5.15 newtons times by 1.35 meters times by -1. So WF is -6.9525 joules. So to sig digs, -6.95 joules. So this is a good example of negative work. Because when you think about it, the force of friction should be a negative work. Because it's working against the direction of motion. So that makes sense that we should have a negative value. So now just make sure you know how to do that. Rewind the video if you need to, and then start the next one.